Okay, we'll go ahead and get started. I presume you're still hearing me. Yep, I think my mic is still on. Thanks everyone for joining today. This is MPLS working group session in IETF 110. It is a virtual online meeting. We are meeting today for 2 hours. Myself, my name is Tariq Saad. Loa Anderson and Nick Lehman are the working group chairs for this working group, and we have Mac Chen as our working group secretary. There is another session. It's a joint session with PALS.NET Spring working group on Friday, session 1, and it's dedicated to discussion about certain aspects of MPLS architecture, as well as the related working groups. I encourage you to attend that meeting as well. This is the Note 12. It governs the contributions and participation in IETF. For people who are new to IETF, we encourage them to go through this Note 12 and get acquainted with it. Some administrative pointers. Blue sheets, you're not going to have to sign your name as usual. The rest is pointers to helpful material about this session. Agenda bashing. We have 10 items on the agenda today. Some of the items that will be presented today are also presented on Friday joint session. We're asking, the chairs are asking the presenters that are presenting on Friday to restrict the presentation and discussion to the solution, and take further architectural discussions or relation with other proposals or solutions to the Friday session. Other than that, we ask the presenters to stick to the time allotted to the slot and leave some room for the questions and answers. Anyone has any feedback on the agenda, please speak up. I'm going to have to count on you, Nick, or Loa, to let me know if there's anyone on the mic. Otherwise, I have to keep flipping to the shared window, to the original home window. So again, we have 10 items on the agenda today. Okay, there's no one in the queue. Yes. All right. In terms of errata, we have one errata that was reported since last IETF 109. This is an editorial errata. It's a pointer to a section that doesn't exist. I think it will get accepted. In terms of liaisons, we didn't have anything since last time we met. In terms of the document update since last time, we have 2 new RFCs that were published, and we have two documents that are in the RFC editor queue, and another 2 in the IESG review. There were 2 new working groups that were adopted since last time. I'm going to go quicker than usual this time over the update to leave room for the other discussions and presentation. But please let me know if there's anything you expect we elaborate on. Again, we're showing the documents that were updated the working group documents here. Some of the documents were expired. We'll have to follow up if these will be revived again. The documents listed in blue color are on the agenda. So these are individual drafts. And with this, I'm gonna stop and ask if there's any comments or feedback. Any individual wants to comment before we start with the presenters. Okay. All right. We're going to start. Next up is the MPLS MSD Yang model with Yingshan. Yingshan, can you hear me?
Yes. Hi.
Hi.
Hello, everyone. This is Yingzhen from FutureWay. I'm going to present a Yang data model for MPLS MSD. Next slide, please. So let's start from what is MSD and why did we write this module. So MSD stands for maximum seed depth. It is the number of seeds that a node or a link can support. It's defined in RFC 8476 and RFC 8491. So you may have noticed that the authors of this draft are the authors from segment routing Yang model. We originally had part of the MSD Yang defined in the segment routing MPLS Yang module. And it was decided during IESG last call that MSD is more a characteristic of MPLS rather than SR specific. So we decided to put this into a separate module, which augments the MPLS base Yang module defined in RFC 8960. Next slide, please. So this slide shows the tree diagram of this module. Basically, it has the, at node level, it has a list of MSDs with different types. And at interface level, each interface has a list of MSDs with different types. It's a very simple, small, straightforward module. So at this moment, we have everything as read-only because we consider MSD is a from the hardware. It's a character from hardware. It's not configurable. If any implementation that supports configurable MSD, please let the authors know, and we may make it configurable. Next slide, please. In the module, we also defined a grouping that can be used by other modules if they want to support MSD. Next slide, please. So next steps, we'd like to collect and address comments. And since it's a very small, straightforward module, we'd like to request working group adoption. And that's all.
Okay, thank you. Any questions? I think I have a question. I'll get into the queue if there's no one else. Okay, I think there is no one but me. My question is, I saw there was MSD type. I'm not clear. Is it the type data plane type, or what type
It's
is it?
it's really MSD type. So right now there are two types defined. If you there is actually an ICP registry for the type. The current two type defined as identity in the module. One is I think it's just the basic MSD type. It is the number of labels a node or link can read. And the second one is entropy, ERLD, entropy readable label depth, as defined in a different draft. We have reference pointers in the draft if you want to
I
know
see.
the details.
Okay.
Yeah.
Okay. Okay. Thank you. Any other questions? If not, we will transition to the next presenter.
Okay. Thank you.
Thank you. Thank you, Yingshan. Next up, we have Deepti on the egress TLV for NILFAC. Deepti, or okay. I hear.
Are you able to hear me?
Yes.
Okay. Hi everyone. I'll be presenting egress TLV for NILFAC. The first document draft we have presented in IETF 109, and this is a follow-up draft with co-authors from Cisco, Zafar Ali and Nagendra Nair. Next slide, please. So, in this presentation, I will be discussing the updates on the draft, the review comments which were given from the last IETF, and the next steps. Next slide, please. So there was a confusion in the introduction and abstraction key. It was taken as a only Spring T extension, but the draft is an extension to the NILFAC. So many times it is not possible to have the FEC validation due to some of the FEC not supported on some of the routers, like routers are not upgraded or the FEC is not present, like for binding SID or the static label. So in that case, we cannot go for the FEC validation. To overcome these things, we went for the NILFAC. Now NILFAC has different problems, which is like misforwarding can occur, uh, and there is no egress validation even if the uh, trace route and the ping is successful. So to overcome NILFAC standard and make it possible to trace any path irrespective of which protocol it used, we came up with the egress TLV. So egress TLV is the extension to NILFAC. The NILFAC processing, there is no change. It is just added as a this TLV is added as a to validate the egress of the complete path. Next slide, please. In procedure, depending on the inputs from other vendors and the explanation is updated using the diagram, and the procedure is made more explanatory. Next slide, please. These were the review comments. So the first review comment was why the draft, generic SID draft and this draft cannot be merged. So after speaking with the author of the generic SID draft, we came into the conclusion that both drafts are for different purpose. So the validation level for both drafts are different. On egress TLV, the minimum validation happen on the data plane with only egress IP is validated, whereas the SID level you are actually validating the associated SID on every path. The second is for egress TLV transit router, if supporting the NILFAC, you don't need to upgrade the transit router. Only ingress and egress need to be upgraded. That is not the case with the generic SID. For generic SID, we need to upgrade all the routers. So after discussion with the authors, uh, we decided to have both the drafts separately as two different standards, since they are on different level. Next slide, please. One of the review comment was कि the number of labels and FEC in the respective stack should be same. So yeah, RFC 8029 doesn't say it should be always same. The section given here are the one which actually tells how the NeilFEC is processing. So since we are not changing any NeilFEC processing in this draft, it is just egress TLV is added to validate the egress of the path. I think we should be okay with this comment. So next slide, please. One of the question was ki how the egress TLV prefix is derived. So if it is the adjacency set, label set, or any kind of set, the egress TLV prefix is not decided on the based of the label used in the path or the LSP used in the path. It is the egress of the complete path. So where the path ends, that will be the prefix for the egress TLV. So irrespective of any set you used in the label stack or label, will the egress TLV prefix will be the end of the path. Next slide, please. Uh, your comments, suggestions are all welcome and greatly appreciated. So it is, since it is a very simple extension to NeilFEC, and we got a request from the operators to take it as a standard as early as possible. We request for early code points and request adoption as early as possible.
Thank you, Deepti.
Thank you. Yeah. Thank you. Any comments?
Let me see if there's anyone on the a bit of I don't see anyone on the mic. So thank you. Your request for adoption will be recorded, and the chairs will discuss it and take it forward. Thanks, Deepti.
Thank you.
Okay, next up we have Shraddha and team on the interdomain OEM for SR networks.
Hi, hi Tariq, are you able to hear me? It's Kapil.
Hi, Kapil. Yes, I can hear you.
Yeah. Hi everyone, I'm Kapil from Juniper Networks. So I'll give an update of this draft from the previous IETF drafts. Next slide, please. Yeah, so agenda is update from the last version. We have got few comments about segment sub TLV and SID type structures and asking for INA update, INA allocations. Next slide, please. Just to set the context for everyone, so this draft was added to support interdomain ping and trace route. The response for ping and trace route comes via IP. So in the interdomain case, egress will not have IP connectivity to ingress. So ingress can add a reverse path segment TLV, which will give us the MPLS header for the reply to come back from egress to ingress. So few points. This is an optional TLV, comes in echo request. It can appear in any order before or after target FEX tag TLV. There should be no assumption that it will follow any TLV. It may appear in echo reply message in the case we are doing trace route and building TLV, building it as we go and go and trace the network. It can be built dynamically also. So yeah, this was just to set the context. We'll come to the changes in the next slide. Next slide, please. Yeah, so initial sub TLV, there is no change in the sub TLV's logic, but the initial sub TLVs was referring to IDR segment routing policy draft. We got a comment that we should define specifically in this draft, and it should be in the format of that the TLVs using the MPLS OEM. I think the type and length had a different different size in the segment routing policy draft. We have specifically defined the sub TLVs in this draft, but it will still map to the same TLV types, same types in IDR segment as IDR segment routing policy draft. This is type 1 sub TLV, where you can specify the label, which label to use to come back from egress to ingress. Next slide, please. So after type 1, if you notice, is type 3. Type 2 is SRv6 sub TLV, and this draft and SRv6 out of scope for this draft. So this in that's in separate effort, and it will be taken up separately. So again, this sub TLV gives a node address and a SID optional. So the egress can use this to calculate the path to come back to ingress. This is for IPv4. Next slide, please. Type 4 is for IPv6, the same TLV for IPv6. Next slide, please. Yeah, and this is a request for INI allocation for the same. For all these sub TLVs for MPLS label, IPv4 node address, and IPv6 node address sub TLVs. Next slide, please. So this is a pretty simple and stable draft. We haven't done much changes other than specifically moving the TLVs from IDR to and reference from of the TLVs from IDR, and specifically defining here a request and adoption for this draft. And that's all. I think if there are any comments or questions, I can take it up.
I see there are.
Yeah, two people in the queue and one remark. Loa has problems with audio, so I'm currently debugging his audio settings. Just let you know.
Okay.
So this is Mark. I have a
Go ahead, Mark.
have a question. Okay, so I think there's a RFC called RFC 7110 define the reply path here that is used to specify the written parts of RSP pin. I think the use case for this draft is valid, but I think maybe it's better to use that TLV to define extensions based on that TLV to define relevant extensions.
So is this the same TLV? I've not checked the RFC. Probably I can check it, and we can discuss on the email chain.
Okay.
So you are saying about some specific. I have not seen the RFC. Which RFC you're talking about?
It's a general TLV that is used to carry the written path information. How to specify the written path? It can be there is already defined several written paths.
Okay, so basically this is specific to NSI. This is basically specific to SR networks because we have different sRGB and things like that. That's why we have given a choice to the responder to select. To come up with a label in one of the sub TLV. If the same sRGB is a choice for the label. Other than that, there are cases where if there are two inter-AS networks connected by EPE, so if you go over the draft, it explains how to learn it. How to build it dynamically when as soon as traceroute goes on.
Okay, I think we can discuss offline.
Yeah, sure.
Okay.
Okay.
Greg is next.
Greg, okay.
So I have a question about your type 1 TLV. Have you looked at Spring BFD document? Spring BFD document introduces non-fact TLV to define the return path for the reverse path for the BFD session. And non-fact TLV, it does include the stack of labels, and it's specifically for the SAR MPLS use case.
Okay. So I think Greg, I think you brought it up earlier in an earlier earlier IETF also, and I remember we spoke about I think your the defined TLV in BFD was specific, or only had equivalent to type 1, right?
Yes. Well, because everything else is already, as Mac pointed out, covered by RFC 7110. So the combination of RFC 7110 and Spring BFD draft, working group draft, covers all the cases that you present here, in my opinion.
I think it also covers how to dynamically build the stack when as traceroute goes on.
Yes, but that's probably would be informational, not really standard track. But that's my opinion. Let's take it to the list.
Okay, I mean, yeah, we can discuss in the email chain. Okay.
Yes, thank you.
All right, thank you, Greg. Anyone else in the queue?
No, it's empty now.
Okay. All right, thank you, Kapil. We will take it to the list like was suggested, and I guess you're asking for adoption of this document.
Yes.
So
yeah.
we will monitor the discussion, and the chairs will we will record your request and discuss it among the chairs.
Thank you, Tariq. Yeah.
Thank you. Okay, next up we have Nagendra on supporting flexible algorithms, prefix sets in LSP ping traceroute. Is it Nagendra that's presenting, or I can double check? Yes. Is Nagendra on the call?
Yeah.
Okay. All right.
But
I can see you and I can hear you.
okay.
Take it away. Hi, Nagendra. Can you still, are you still in the meeting? I guess. I can no longer hear you.
Okay, now? How about now?
Yes,
It works now.
I can
Yeah.
hear you now.
Yeah. Finally. Thank you. Hello, everyone. I'm Nagendra from Cisco. I'll be presenting this draft on behalf of my co-authors. Next slide. So this draft basically identifies a gap in the existing definition and tried addressing the same. So the problem is the problem statement here is RFC 8287 defines the the LSP pings targeted FEC stack and the semantics for initiator and the responder for to validate the LSP paths in segment routing network with MPLS data plane. Now, this is an example of one of the prefix set. As you could see, the targeted FEC stack is currently defined in a way that we define the prefix, or we include the prefix and the length, along with the protocol that is used to advertise the mapping, the SID and the prefix mapping. So this information that we carry currently with the targeted FEC stack is sufficient to validate single topology or the default flex algo scenarios. But when we apply this in multi-topology or the scenarios involving flex algo, the non-default flex algo, this information may not be sufficient to perform the validation. Next slide. So we have it explained with one of the example topology that involves multiple flexible algorithm. So as you could see in this topology, node 9 is advertising prefix 1.1.1.9 by associating it with 3 different flex algos. So as you might be aware, for each flex algo will be having unique prefix heads. So the prefix head 16009 is advertised for flex algo 0 or the default flex algo, and 16809 is advertised for algo 128, and 16909 is advertised for flex algo 129. Now let's imagine a scenario where node 0 would like to perform the validation for a specific flex algo. In this case, 16809 for algo 128. So when the probe is generated from node 0 and when node 9 receives the packet, it may not have sufficient information because we just included the prefix, which is 1.1.1.9, and the respective subnet mask along with the protocol that is used to advertise. So now node 9 may not have the relevant information to validate if it needs to be validated against flex algo 0 or 128 or 129. Now based on the implementation on how the prefix is associated in the respective table, it may even end up sending a false negative saying there is a label mismatch. So this draft is proposed to tackle this problem. Next slide. So this draft basically does 2 things. One is to extend the existing targeted FEC stack sub-TLB defined for IPv4 and IPv6 prefix set. And the next one is by proposing new targeted FEC stack for multi-topology. So let's now first look into the extension of the existing one. So the IPv4 and IPv6 prefix segment ID, which are defined by RFC 8287, have a field of 16-bit, which is reserved. So this draft split that 16-bit reserve field into 2 different fields. And the 8-bit, the first 8-bit field is used as the algorithm field. So this is backward compatible because if it is the default flex algo, then the value will be 0, and so all the 16 bits will be set to 0. So this is backward compatible to the existing implementation, and if the validation needs to be done for a non-default flex algo, the respective algo field will be included in this new field. Next slide. So the next one is defining new targeted FEC stack for multi-topology. So in addition to the previous one, which is prefix, the length protocol, and the algo, the multi-topology extension is included. So this is a new targeted FEC stack sub-TLB being requested to the INA. So the multi-topology ID is appended to this. So this will be used to identify which topology that we are trying to validate. And this draft proposes this extension for our new targeted FEC stack sub-TLB for both IPv4 and IPv6. Next slide. So the same example that we saw in the problem statement has been explained with the flex algo example here. So again, this is applicable for multi-topology as well. So going back to the same topology, now with the introduction of these new fields, like for example, the algo field in the targeted FEC stack, when node 0 would like to validate the LSP path towards prefix 1.1.1.9 over the algo 128, it can include the relevant algorithm ID in the targeted FEC stack that could be used by node 9 to perform the validation against the right control plane entry, and it can send the relevant response to the initiator. Next slide. So the constated, this draft was inactive for some time, and we resurrected the draft, and we have new co-authors joined us from Juniper. We as a next step, we are seeking the work group's feedback. So please feel free to read and share your comments. Thank you.
Any questions? Thank you, Nagendra.
Yeah. Thank you, Daniel.
I do have a question if there's no one in the queue.
Sure.
Okay, I think I'm the only one. My question is about flexible algorithm. The term flexible was for, if I'm not mistaken, was for the user-defined range from 128 and onwards. Does it cover the standard algos as well? Is it the correct term that you want to use?
Yeah. So I mean, it includes the standard algorithms as well. So yeah, that's a good comment. We can
yeah, just I can't remember right now if Flex Algo covers the whole algorithm space or just the user-defined one.
Yeah, we'll check that and we'll update the terminology accordingly.
Okay, thank you.
Okay.
Okay. I guess nobody's on the mic. Thank you, Nagendra.
Yeah, thank you.
We'll move on to the next presenter. And we have Yao or Greg on MPLS-based service function path, consistency and verification.
Hi, can you hear me?
Yes. Yeah, hi.
Okay.
I can hear you.
Yao from, hi, I'm Yao Liu from ZTE. My presentation today is about MPLS-based service function path consistency verification. Next slide, please. The requirement is to evaluate MPLS as a pin mechanism to support verification between the control plane and the data plane for MPLS-based service function path. In this draft, MPLS-based SFP includes MPLS SFC in IFC 8595 and SRSFC in the SR service program draft. For MPLS SFC OM, this draft proposes that service function forwarders are responsible to process the MPLS echo request and expand the usage of the generic associate channel label to identify the SFP OM packet. And new sub-TLVs are introduced for the FEC of the MPLS basic unit for SFC. As for SRSFC-OM, it is based on LSP pin for SR MPLS. Next slide, please. This draft has been presented on last meeting, and here are the updates since then. First, MPLS SFC-OM and SR SFC-OM are separated and discussed as two independent topics. Second, the solution is modified to be more consistent with the LSP pin mechanism. SFC validation TLV and its sub-TLVs defined in the previous version are deleted, and SFC basic unit near sub-TLV is defined in this version. Its usage will be described in the following slides. We also add a reason about why in MPLS SFC, service function forwarders are responsible for MPLS echo request processing. That is, in MPLS SFC, the packet forwarding decision is made by service function forwarders based on the basic unit. Service functions may not be aware of the FEC or the label stack. And note that the draft updates IFC 8595 is added, and the paragraph in IFC 8595 that this draft wants to update is changed. The terminology section is updated for better understanding, and there are also various editorial changes. Next slide, please. And these two sub-TLVs are defined only for SFC and MPLS. Packet forwarding in SFC and MPLS is based on the basic unit for SFC, which is two labels. So the SFC basic unit sub-TLV is used to carry the corresponding FEC info of the basic unit. The RD and SF type fields are taken from its control plane draft. In SFC and MPLS-OM, since one basic unit is related to only one FEC, to ensure that the proper validation can still be performed, the SFC basic unit near sub-TLV is introduced. It is a bit similar to new FEC, When during FEC validation, a service function forwarder should skip the new subtier V and use the SFC basic unit subtier V to validate the FEC of the basic unit. Next slide, please. And this page summarizes the theory of operation when sending an MPLS echo request in SFC MPLS. The echo request is sent with a label stack corresponding to the SFP being tested. One or more
You're breaking up for me.
also be carried.
Is it just me or everybody's hearing the
No,
voice?
it's same here. So it's not only you.
Okay. Yao, you may want to repeat the last sentence. We could not hear you well.
Can you hear me now?
Yes, I can hear you.
Okay. The network condition is not so well, so I'll continue.
Okay.
So downstream detailed mapping theory may be included, and operator should manage the TTL field of the SF label properly to trace and service function path. Next slide, please. And here gives two examples of sending the MPLS echo request. The left is a service function path based on the swiping mode. The MPLS echo request is sent with one basic unit and one GAL in the packet. The TTL of the SF label is set successively to 1, 2, 3, and so on. And the right side is an SFP based on packet mode. If the operator wants to validate the FEC for SF2, which is connected to SFF2, the GL is putting two basic units in the echo request, because when the packet leaves SF1, the first basic unit and the GL in it will be swiped. In the FEC step, the basic unit near subtier V of basic unit 3 may be carried. It is in order to ensure that the number of labels in downstream tier V correspond to the number of FECs in the FEC stack. So SF2 also can enter the FEC validation procedure as an intermediate node. And this is the next slide, please. Okay. This is the packet processing flow of the service function forwarder after receiving an echo request. As introduced before, if the SFC context label is followed by a special purpose label, GL, it is recognized as an SFP OM packet. Then the SFF will decrease the TTL in SF label. If the TTL after decrease is not zero, the OM packet is processed as introduced in FC 8595. If TTL is decrements to zero, the OM packet is sent to the local control plane. Next slide, please. And IFC 8595 specifies the processing rule of the TTL field of the SF label. One of them for the swiping mode is if an SFF decrements the TTL to zero, it must not send the packet, it must discard the packet. To specify the rule 2, if an SFF decrements the TTL to zero, an OM packet may be sent to control plane. Given it does not exceed the configured rate intended to protect the system from the possible DOS attack. Next slide, please. And we welcome feedbacks and comments. And because SFC, MPLS OM, and SR SFC OM are separated, we plan to split the draft, and only the SFC MPLS OM part will be kept in the draft. and we'd like the working group to consider adoption of SFC and MPLS OEM. And that's all. Thank you.
Thank you, Yao. Let's check if there are anybody in the queue for questions.
Yes.
I see some. Yeah.
Nagendra, and then you are.
Yeah, thank you. So, I was looking into the theory of operation that you defined, and I understand that this draft is targeting both, the legacy MPLS and also the segment routing MPLS for SFC. I mean, the SR based SFC is going to be a stack of segments that will steer the traffic, be defining the relevant service functions. So I'm trying to understand how this theory of operation is sufficient for SR SFC, because it simply says decrement the TTL in SF label, which may not be the case. And if we were to directly pop and steer it to the next service function without any additional check on the transit SFFs, then I'm worried we are not actually doing the actual validation. We are. It's more like forwarding it towards the next service function forwarders. Any thoughts on that?
Sorry that the network didn't work well, so I only hear part of the question. So first, if I don't understand right, you can correct me. And if the in this draft we in the next version we're only going to discuss about the MPLS SFC defining FC8595, and you will leave the SRMPLS FC to another draft. So is your question based on this?
Yes, it's more on the SR SFC because I understand the legacy MPLS validation, but SR SFC to me it looks like the theory of operation may not be sufficient. So just want to get some clarification on that.
If I may, this is Greg. Sorry to interject because of your network condition. So currently the draft covers only MPLS SFC case. So it's not applicable to legacy. It's not applicable to SR SFC. It's specifically for RFC 8595. Does it answer your question?
Yeah, because I remember saying something around. I know this draft covers both SR SFC, so just want to get a clarity.
Well, that's okay. That's something that we're still discussing. We are open for, and we appreciate the comments from you in the working group, because we realize that these use cases are different, and they either require different instruments or might be just a separate draft. But current solution applicable only to MPLS SFC covered by 8595.
Okay, thanks.
So then Loa is next.
Hear me?
Yeah.
Okay. And I had a bad echo. Can you go back to the slide that talks about sub-TLVs 16 and 21?
Need to help me on which slide exactly you want me to go back?
Okay, so that's
the good
one.
Okay.
Yeah. So all other sub-TLVs are defined for TLV 1 and 21. Is that true this case also.
I'm back again. Can
Did you
me?
hear the question now?
No,
Oh.
I see now. It's the text on the slide. This is confusing. So I withdraw the question.
Oh, okay. Okay, so you're clear, Loa. Can we move on to the next?
Tarek, you are next.
Okay, good. My question is about the presence of multiple gals in the stack. If I remember correctly, the gal, when it was proposed, it was to be at the bottom of the stack, and the gash follows it. Are you updating in the RFC that mentions this?
Oh yes. What? Because the service function forwarder needs to identify that packets are OM packets in some ways. We think it's appropriate to use special purpose label to indicate that. Among the existing special purpose labels, the GL is maybe a suitable choice to identify the packet that this is our own packet. Yeah, I'm aware that in the RFC now, the GL there's only must not be more than one GL in the packet. So if after discussion and the working group think that using the existing special purpose label is not suitable, we can consider to use a new special purpose label. But I think, yeah, we can discuss more about that.
Okay. Yeah, just follow up on my question. Some hardware will assume that once they see the gal, the next is the gash, and there's specific bits that should follow for the gash header. At least the first nibble, first 4 bits. And I see here you're assuming an SF label without any regard to the first nibble. So we can take it to the list, but I think this has to be thought of more.
Okay, we can discuss more about it.
Okay, thank you. Anyone else in the queue?
No.
Okay, thank you, Yao. We'll move on to the next presentation. We have Rakesh on the MPLS data plane encapsulation for in situ OEM.
Hi everyone, my name is Rakesh Gandhi, presenting this draft on behalf of the authors listed. Next slide, please, Tarek. So the agenda is we'll look at the requirements and the scope of the draft, the summary of the procedures. There is some discussions happening in this session, as well as we have a joint PALS Spring MPLS working group session on Friday, and discuss next steps. Next slide, please. So the requirement and scope of this draft is this is about the in situ OEM. The work is being done in the IPPM working group, where the data fields are defined, and the scope is to carry that with MPLS and CAP for both the edge-to-edge case as well as hop-by-hop IOM case. Next slide, please. So we had the MPLS RT expert review done. Many thanks to the reviewers. we have defined a new IOM GSCH header with a new type for IOM. There were some requests to elaborate on IOM procedures, so we have done that as well. We clarified that label usage with respect to the IOM option types. There is some discussions happening for multiple GSCH and control word handling. Draft does talk about that, and probably there might be some more discussions in this area. Some editorial changes about not scope is not just SR, but is generic MPLS encapsulation. So editorial changes were made for that. And then open item is to discuss the multiple GSCH control word headers. Next slide, please. Next slide. So a draft defines the GSCH header for IOM with a type for it. This allows to handle the ECMP related issues because it starts with 0001 bits. And it's followed by IOM options that's defined in the IPPM working group documents. And next slide, please. Yeah, so we just mentioned the header, so we can go to the next slide, please. The second extension being used are the indicator labels. They are used to indicate the presence of the IOM data fields after end of stack. The separate labels are used for H2H case and hop by hop case. Idea is to optimize the processing on every hop. It's a heavy processing and trying to avoid the processing on all the mid nodes. And in case of hop by hop case, the trace options are processed on each hop, but as well as the edge nodes. Whereas in edge to edge case, it's only processed on the edge nodes. And next slide, please. Next slide. So this is a packet for a header. There is an indicator label with end of stack bit set for edge to edge case, followed by the IOM GACH, and it's followed by the IOM option types, and then the payload. So this is an example of edge to edge MPLS IOM packet header. And next slide, please. So there are three methods for the edge-to-edge indicator label allocations. One method is to define standard extended special purpose label, which is used along with the extension label 15. Second method is to have a global label, which is can be allocated by a controller, in which case you only have one label. In case of number one, you have two labels. And there is a third case where the label is signaled by the decap node. This also helps with making sure that the decap node is capable of processing the IOM, because it will advertise the label. And in all three cases, the label is carried at the bottom of the label stack. Next slide, please. So this is a comparison table for the three methods. What is the impact of the label stack size, and where does the indicator label added on the label stack? So the ESPL, there are two labels as mentioned, whereas in method 2 and 3, it's only one extra label, and it carried at the bottom in all cases. And next slide, please. So the procedure is on the NCAP node. The MPLS header is added as well as the indicator label and the trace options for H2H case. And midpoints do not process. They will not find any indicator label that they need to process. So they will skip it. Decap node will process, will find the indicator labels. It will process the IOM and it will decap, remove the IOM data, and it may take a copy of the packet along with the IOM data for further processing, which could include telemetry, for example. And after decap, removing the IOM label as well as data fields, it will forward the packet just like any data packet it processes. Next slide, please. So in case of SR-MPLS, there is a label stack. This was to answer a question, where does the path segment go in this case? So path segment would be added just before the IOM indicator label values. The path segment can identify the path, but it can still be used along with IOM headers. And next slide, please. And next slide. So the hop by hop IOM, again, there are three methods. This one shows an example of using one case with IOM FEC label. This would be the top label on the incoming packet. This is one example. And we will see there are three methods as well in the next slide, please. So just like the H2H case, there are three allocation methods. One is being the standard extended special purpose label using with extension label 15. There can be a global label allocated by a controller, or an FEC label, IOM label, advertised by the intermediate and decap nodes. In this case, the label is carried at the top of the label stack, whereas in the previous, the other two methods, they are at the bottom of it. Next slide, please. This is a comparison of the three methods, pros and cons. In case of number one, the special label, you have two extra labels. The global label would be one. And in case of the FEC label, it's just the regular label with IOM enabled, so no extra label on the stack. In case of number one and two, they are at the bottom. Number three is at the top. Just the one salient point about number three is that if you have a different traffic, one with IOM enabled, one without, you may have different fee entry that needs to be processed. And next slide, please. We will skip this. There is no IOM processing at the, there is extra IOM processing on the mid nodes, but this is the only difference. Next slide, please. Next slide. We can go to the next slide with the picture. So in case of, so this is being discussed, and so there are some other proposals for this issue as well. So in the draft, there is a case with a pseudo-wire label packet that exists today. For example, how would IOM would be carried? So it would be carried between the pseudo-wire label and control word. The IOM label would be at the bottom. So this way, any intermediate node can easily find indicator label at the bottom with EOS 1 and do the processing for IOM. IOM processing can be heavy. It can be on every node. So it's a well-known location, but it does get removed. So once you remove IOM indicator label and the data fields on the decap node, and then you have your pseudo-wire label and control word in the packet, and then you continue the regular processing. The labels stay where the labels are today in the MPLS header, and the metadata stay together where the metadatas are there today. So there is no change in the architecture for MPLS. This should not break any network, assuming that IOM is supported and enabled on the node. Next slide, please. This is an example with another control word, another GSCH type. In this case, it's the same idea. We have pseudo-wire label or indicator label at the bottom. You process IOM and then remove it from the stack, and what you have is another GSCH channel. These are metadata can be seen like TLVs. So you know the type, you know the length for it, and you can just find the next metadata. And there is one-to-one mapping between the label and the metadata anyway, so there is no ambiguity. Next slide, please. Welcome your comments and suggestions. We will have some more discussions on Friday as well on the last topic with multiple GSCH and control word. And we are requesting working group adoption for this document. Thank you.
Thank you, Rakesh. Nick, anyone in the queue? Let me add myself as well.
Yeah, Kireti is in the queue.
Kireti, go ahead.
You can hear me?
Yeah.
Yes.
Yeah, I just wanted a quick pointer forward to the draft I have below regarding the special purpose labels being used in this draft. Actually, it applies to a few other drafts that have been presented today. So I would ask people to wait for those slides and understand what the proposal is and how that changes their request for special purpose labels. Thanks.
Thank you, Kiriti.
Thanks, Kiriti.
So Tarek, you are next.
My question, Rakesh, is about the edge-to-edge special purpose label. Since you're going to assign a new gash type for this IOAM metadata, why not use GAL, the already allocated special purpose label? It is the one that indicates there's a gash following.
The way it's defined, the GAL on the decap node will punt the packet. And in this case, we are forwarding the packet. This is carried by data packet. So packets get forwarded downstream. Whereas in case of GAL, which is used for OAM packets, they get terminated on the node. So that's how the GAL is defined. But definitely if there is existing network with that behavior, we could update the RFC, but there is an implication on the existing network.
Okay. Thank you. I guess you are going to consider the case, or you already considered the case of presence of a GAL within the stack. And is there any order you're dictating and processing the payload of MPLS? Normally,
So,
the gal follows the gal immediately. I presume you are going to shuffle around things.
you need to understand the requirement, because the IOM is carried by the data traffic, and the GAL is carried by the OAM packets. So you don't have, at least typically, you don't have a case where you have both OAM and data. They are different traffic, right? So you don't have that case. But if there is some scenario, we can talk about it.
Okay, I don't have a case yet, but I don't think we can just assume it will never happen unless you state that in your proposal. Explicitly state it should not, must not.
Yeah, we can say must not, and because it's GAL is meant for OAM, and this is meant for data packets, so we can definitely state that.
Okay, thank you, Rakesh. We'll follow up on the list.
Thanks, Tariq.
There's no one else in the queue. We'll move on to the next presentation. Thank you, Rakesh. Next, we have Jidong for carrying VTN ID in MPLS.
Yeah. Hi, Tariq. Hi, everyone. Can you hear me?
Yeah.
Yeah. Okay. This is Jiedong, and I'm going to present this topic on carrying VTN ID in the MPLS packet. Okay, next slide, please. Here are some background about this work. The term VTN was introduced in the enhanced VPN draft in the TIS working group, which is basically a virtual underlay network with a customized topology and a set of dedicated or shared network resources. A VPN can be used as the underlay for one or a group of VPN plus services, as shown in the picture in the right side. We can build multiple VTNs based on a shared physical network, and each VPN can be used to carry one or a group of VPN overlay services, and the overlay VPN, and together with the VTNs, will provide the VPN plus services to the customers. In order to guide data packets to be steered to the set of network resources allocated to the specific VTN, the information of the associated VTN needs to be carried in the packet header, and the VTN information needs to be processed along the path on each hop to ensure that the consistent packet forwarding with the VTN context can be assured. So in this document, we propose a mechanism to carry the VTN identifier and the related information in the MPLS packet. This mechanism is applicable to both SR-MPLS and the traditional MPLS networks. Next slide, please. Okay, this page, we summarize the mechanisms in this document. Basically, a new header called VTN header is introduced to carry the VTN ID and the related information. This header follows the MPLS label stack and precedes the header and the payloads of the upper layers. The existence of this VTN header is identified by a special purpose label called a VHI, VTN header indicator. The format of this VTN header is shown in this picture. We need a nibble with the value 0010 to ensure that it is not interpreted as an IP header or ACH or control word. The length field is used to identify the length of the header in 32-bit words. And then we have this flags and reserved fields. After that, we have the VTN identifier, which is a 4-octet identifier. We may also carry some optional information about the services carried by this VTN. This length can be variable. For example, in the context of 5G network slicing, this can be the SNSSAI for the 5G network slices. Okay, next slide. Here are the procedures of this VTN header processing on the ingress node. It can encapsulate the VTN header together with the MPLS label stack according to the traffic classification or mapping policy. On the transit nodes, each node which can support this VTN processing, you look for the VHL in the label stack. And if there's a VHL, its forwarding will be based on both the top label and the VTN header. The top MPLS label will be used to determine the next hop, and the VTN identifier will be used to identify the local set of resources allocated to the VTN for processing this packet. And a service differentiator may be used to provide some finer-grained differentiation and processing. On the egress node, the VTN header and the VHL should be popped, and to avoid this information leak to the another domain. Okay, next slide. Some considerations about the capability, advertisement, and the negotiation. Before inserting this header into the packet, the ingress node needs some information about whether the nodes, including the egress node and the transit node along this path, can process this VTN header properly. So this we need some capability, advertisement, and the negotiation mechanism. But this will be provided in a future version. Next page. Okay, I think this is a straightforward extension. We would appreciate comments and feedbacks from the working group. Thank you.
Thank you, G.
So in the queue, first Tarek and then Stuart.
Oh, okay. I'm still in the queue. I do have a question, but it wasn't meant that I am in the queue. I'll take advantage of that. My question is related to the presence after the end of stack, the VTN ID. What if the transit node cannot read beyond the end of stack? Did you any considerations about this problem?
Yeah, I think that belongs to the capability advertisement, which each node need to advertise whether it has this capability to process this VTN header after the label stack.
Okay.
Is that what you mean?
No, I mean if there's something called readable depth, and if I cannot read beyond the readable depth, I cannot reach the VTN ID. Then there are other proposals, G, where the ID, that this slice ID or VTN ID, slice aggregate ID, we call it, is within the label stack, not after the end of label stack. So yeah, I guess maybe we should think more about the presence. Where do you want to put this identifier? Is it in the stack or after the end of stack? And what are the implications in both cases?
Yeah, I agree. There are several candidate positions to put this information in the packet. And actually, there each has its pros and cons, such as if we use like a header after the label stack, we have more flexibility to define its format and the length, and maybe it can be also variable length. This is some benefit of this. Also, as you mentioned, there's some cost we need to consider. So each one, we may need some more discussion about all these candidates.
Okay. Anyone else, Nick, in the queue?
Yes, Stuart and then Jeff.
Okay, I'll remove myself then. Okay. Stuart,
go on.
Stuart, please go ahead. We can't hear you, Stuart.
I'll type it in the. Oh, it's working this time, isn't it?
I can hear you now.
Thank you. Sorry about that. Right.
No problem.
So we need to add this to the long list of metadata after the stack, of which there seems to be, every time I look in the MPLS area, there seems to be another one. So we need to add that to the list to decide what we're going to do as a community about this, and that's part of the reason for the Friday discussion. But I would add another point, which is this sequesters 0010 after the stack. Now, many years ago, I would remind people that this alias is with the IP version space. And many years ago, I struck as PAL's chair or Suit PWE3 chair. I struck an agreement with the internet area that we were taking two of them, 0 and 1, and we wouldn't take any more. I see that I think Beer has taken another one. I really think we need a discussion with INT about which of these we can safely take in order not to clip the wings of the IP designers.
Yeah, thank you, Stuart, for your useful information. I didn't realize that kind of conversation before.
It was many, many years ago, and it is because that 00, the 4 zeros and 4 zeros ones are IP versions in the original definition of MPLS. So we have to be careful not to take any more of them than we absolutely need.
Okay, yeah, understood.
So Jeff, you are next.
Hey, I would like to re-emphasize the importance of considering BOS and ERLD. ERLD is supposed to be used within label stack. There's a number of implementations who would look at BOS bit and skip processing, right? So if your header is beyond, ERLD might not represent what it is.
Yeah, that need to be taken into consideration. Yeah, I understand this. Thank you.
Especially given existing implementation. I mean, they'll look for both.
Yes, yes.
Anyone else, Nick, in the queue?
No, queue is empty.
Okay, thank you, G. We will move on to the next presentation then. In the next one, I think we have Julian presenting using entropy label for slice identification.
Hello, everyone.
I can hear you, Julian. Go ahead. Fly away.
Okay. Thank you, Tarek. So I'm Julian Maric, proxying here for my colleague Bruno de Crane on presenting this draft on behalf of the set of co-authors that you can see here in the first slide. So can you move to the next slide, please? Okay, so the idea here is to carry new information within the MPLS stack, and especially the identifier that we could use for a slice for configuration where we require some network slicing information. And this may look like a conflicting purpose with the idea of limiting the size depth of the MPLS header, the number of shim header that we use on the stack, especially in the context of the segment routing MPLS, where we know that the number of labels that we carry on a given packet is a scarce resource. So we'd like to balance between those both principles. Next, please. So the idea here is to consider existing fields that we already carry within the MPLS header stack. So brief reminder on the entropy label principle. It uses two label stack. The first one is the entropy label indicator to mention that there is something special following, and then the entropy label itself carrying the value to be hashed for balancing the traffic over the network over multiple paths. So we see in this drawing that there are some fields here, especially the traffic class and the TL of the entropy label, that may be useless until we associated some semantics to those. Next, please. So the idea of the draft is that we keep the usage associated to the entropy label and the semantic of the entropy field to support load balancing and hashing over the network and transit LSRs over the network. We still allocate the entropy label value from the ingress LSR and push that label within the stack. And the idea here is to make use of the bits from the entropy label TTL, which currently are defined as a reserved field for future uses. And the futures is now. And we propose to allocate some of those TTL unused bits to use them as flags and enable different features depending on the semantics we associate to those flags. Next, please. So to specify the first proposal from this draft is that we define the entropy labels TTL field as a new entropy label control field, which is no more just zeros, but some flags. A flags, it's a byte actually. So on those flags, maybe user defined to be associated to some specific feature. So the idea is to maximize the reusability of those bits to various purposes, not necessarily associate a fixed flag to a fixed feature, but make it configurable to make sure that we can consistently configure various LSRs over the network, and in most cases, consider the consistent configuration between the ingress LSR and the egress LSR, and associate a given flag to a given application inside various implementations. Next, please. The second proposal that this draft is suggesting is to make use of the previous flag set and define a first use case of those flags, which is associated to carry a slash identifier within the entropy label field. So the idea is to set a given flag consistently between the ingress and the egress, and allocate a value within the entropy label field that carries the slash ID in the most significant bit set, and use the remainder of the entropy label field bits as a usual value that is allocated by the ingress node, the ingress LSR, to enable the load balancing on hash feature. So the idea here is that it's backward compatible with the existing processing of the entropy label header. So it doesn't break anything. It just makes use of unused bits. Oh, I lost the screen. Next, please. Okay. So a bit more detail of the processing by the ingress LSR. The typical use case of the entropy label is that the LSR at the ingress of the LSP or the path is in charge of allocating the value within the entropy label. So here we just split the field and give a different semantic to the most significant bits and lowest significant bits of the entropy label field, and we split it with two different semantics, but globally it remains based on ingress allocation. And we use one of the fields from the former unused TTL field as a flag set to mark that we are making use of the slide ID feature. Next, please. So for any transit LSR, one of the main advantages of this proposal is that it doesn't change anything from the processing of the field. The entropy label is just treated as an opaque field on which the hash feature may be performed. So whether the most significant bits carry a specific value or not, it remains fully similar to the initial definition of the entropy label. And in case the flag associated to the slash ID is set, the supporting implementations over the path, along the path, will be able to do specific processing associated to the pair slicing behavior in case something is related to a pair slice processing along the path. Next, please. So to summarize, the main benefits associated to this proposal is that it remains compatible with routers already supporting entropy label. On the new feature, only make use of unused bits within the existing shim header. So no new fields to carry, no new resource to consume. It just enable a particular processing associated to a new definition of unused bits so far. It reuses the entropy label signaling capability on the maximum size depths that we already have progressing in parallel. And it's enable incremental deployments over operational fields because thanks to the backward compatible advantages, it doesn't break anything and can be deployed in a step-by-step basis. So next, that's it. I see people queuing already.
Yeah, Stuart, G, and Jeff.
Yes, sir. So I was looking at RFC 6790, section 4.2, ingress LSR, point 4. The TTL for the EL must be 0 to ensure that it is not used inadvertently for forwarding. There was quite a lot of discussion about this at the time. So whilst you have an interesting idea, we do need to make sure that we aren't derogating any security promises that we made in the past.
Yes, I see your point. I think it's relevant to make sure that it doesn't break anything. So far, I don't see it as different from any field that remain reserved for future uses.
No,
but
no.
If there are some specific issues that were identified at that time, it's worth looking at them. You're right.
Right, so this was about making sure that we didn't get rogue packets in the network. So that's why it was done. And so this is about whether one of these packets could ever get loose in the network with a high TTL and go somewhere strange. That's why we did it. And I think it needs a much bigger consensus that it is safe to remove that safety feature.
Okay, so that's an open issue that needs to be tackled. I see. Thanks, Stewart. If anyone has a view on that, that's probably an interesting thread to start on the mailing list.
It's a good point. I think we need to follow up on that, sure. G, do you want to go next?
Can you hear me?
Yes.
Okay. Yeah, I see this document proposes another a candidate approach for carrying the network slicing information in the MPLS packet header. Yeah, I think this is it mentioned, it reuse some existing special purpose labels, existing MPLS label. It can make the label stack more compact. Well, it may also have some impact to the existing function, and may introduce some limitation to the new function, like the size of the ID you can carry in this existing label may be limited. Another thing is if some nodes as transit node can or cannot support this functionality, do we need some capability advertisement for it?
I'm sorry, I didn't catch your question.
Okay. Let me summarize.
I agree with your first part. With the summary is okay, but the last piece with your question had just a glitch. Could you repeat the last part, please?
Okay. What I mean is, if you basically this may change. It will change the behavior of the transit nodes, right? When they process this entropy label, do you think some capability advertisement will be needed to indicate which node can do that kind of processing, which node will not?
That's an interesting question that could be considered. So far, there is no requirement to advertise this capability, because processing the proposal and the proposed way of the proposed encoding there in the legacy behavior would be completely transparent and wouldn't break anything. So it's not absolutely required to advertise it, but maybe as an enhancement that could be considered. But since there is this flag proposal to make sure that the processing is consistent, it's not necessarily required.
Okay, for the entropy label processing, maybe it's like you mentioned, it's transparent. Well, if we want to ensure that the whole path can do the slice-based processing, you may need some information about the capability on the transit node also.
Yeah, path selection time, when you want to do a very accurate path, yes, that could be a useful parameter to take into account at path selection time. Yeah,
yes.
you're right.
Yeah, my last comment is about the terminology. As you can see, we have the waiting IDs, slice ID, and perhaps a slice aggregate ID, referring to maybe the same thing. Perhaps we need to converge on the consistent description or terminology. Right.
Clearly, yes, this is something that would be valuable to the working group as a whole. I agree.
Okay, thank you.
You're welcome.
Hi, Julian.
Thank you. Next, I thought I saw Jeff. Okay, Jeff, go ahead.
Hi, Jeff.
Hey, so if you're going to use entropy labels for forwarding, then you change fundamentally semantic entropy labels, right? It's optional for load sharing because you just increase entropy. If you don't read it, you can still forward the traffic. You don't load share it, it's good. Now, if it's used for forwarding, it's mandatory to be read. So in segment routing, your ELLI pair can be inserted at any depth, right? So we've got two constraints: how deep you can insert it, how many pairs, which is on ingress node, and then URLD, which is on transit. And they become mandatory since they're used for forwarding as well as on PC computation. You need to impose label stack that is readable across every transit node. I would really like to see these points addressed in the draft. Thank you.
Okay, so I'll share it with the authors, and some of them are attending it there. So
yes, I want to comment just Jeff, to clarify that I don't think we're stating that the slice ID is used for forwarding, but for slice aggregate or slice identification. The forwarding labels are in the stack. So this is just an ID that's embedded inside the, it happens that this is in the entropy, but it will dictate that the packet is part of this slice and nothing else. It's not dictating that changing the forwarding behavior. At least this is my understanding of. I don't think in the
it's
draft
for
we
reason
talk.
data plane, right?
Repeat that, please.
It is for reason and data plane.
It's for slice identification. So you determine the packet belongs to this slice or slice aggregate, and that's what it means.
It needs to be imposed. It needs to be read by someone. Otherwise,
Indeed,
it's
yes.
useless.
Correct.
So
It
you
is
need to make
imposed
sure
and
that it is imposable and readable.
Oh yeah. I totally agree that a transit node should be able to read it, and it should be within the readable depth. I agree with you. That's good.
And 8662 goes in great details how to compute label stack, where to insert it, and it would be great to see it addressed in the draft.
Yes, I agree. Thank you, Jeff.
So Stuart and then Greg.
Let me speak. Yeah. So first of all, I agree with the points that both the sets of points that were just made. It seems to me being no point in putting this thing in a critical part of the forwarding layer if you're not actually going to use it as part of the forwarding decision, and that means that you need to have capability advertisement, and the path needs to verify that the path, all the P nodes have got this capability. So that's the first thing. Second thing is that it seems to me that when you get to slicing, you also get into more sophisticated SLA and SLO, and the technique that was presented earlier, where you put the information under the label stack, if it can be made to work, does allow you to put more sophisticated SLA information down there. For example, latest time of arrival in terms of real time, as opposed to hop count and stuff. So we need to understand what more sophisticated things slices are going to want before we decide how to do slice identification. Because otherwise we'll end up just doing this thing twice, and we'll have all the corresponding issues of interworking between multiple techniques trying to do the same thing.
Yeah, I see your point, Stuart. It's true, it doesn't address all requirements associated to any given SLAs, but for simple cases, this proposal has the benefit of being easy to implement with respect to existing specified features. So it's a trade-off between what we need to achieve and what will be needed in implementation.
But don't forget, act in haste, repent at leisure is the concern.
Thank you, Stuart.
There was another person in the queue.
Are we managing time?
Yes, thank you for the reminder. Greg, can you please make it quick?
Yes, I just want to point that it appears that the wording in TTL for the entropy label is not equivalent to reserved, because it says that TTL must be 0 and it doesn't say it ignored on receipt. So reuse of this field is risky, and I agree. So it's a new capability that needs to be recognized and advertised and matched. Otherwise, it will be unpredictable results, and the entropy label will be used for forwarding.
I think it fully matches Stewart's initial comment, and I guess that Directs agrees to start a follow-up on this issue. So it's probably just the start of the resolution of this issue. Point taken.
Okay. Thank you.
I totally agree. Let's follow up on the list on this. That's an interesting point. And I want to move on to the next slot. Thank you, Julian, for representing the office, and much thanks for that, by the way. All right. I'll move on to the next presentation by Kiriti. Please go ahead, Kiriti.
Hi, thanks. Yeah, before I start, I want to say that we need to do a better job of time management in the MPLS working group. I also think we need to do a better job of organizing. I know that people have put in their requests for slots, and I don't know what the order in which we do that, but I think that needs to a long, hard look.
Thank you.
Anyway, I'm here. Yeah, I'm here. I've got 10 minutes, but that means that the next person after me doesn't have much time. If Julian's presentation had a lot of comments, this will have even more. So I'm not sure how we're going to handle that. But I think this is a pretty important presentation, and that's why. Anyway, I'll stop talking about time and start talking about my slides. So next slide, please.
Thank you.
I should mention that there's a decent set of people who are on this, including Israel Malik from Broadcom. So we've done a little bit of a polling of how different forwarding engines use this, and that'll come in useful. So anyway, the basic motivation here is there are lots and lots of requests for special purpose labels. And typically these special purpose labels ask the forwarding plane to do something. And so, for example, there's the no further fast readout, which effectively says, if you see this and you're trying to do fast readout, don't, just drop the packet. But then there are others that say, if you see this special purpose label, the following label is a slice aggregate, and that tells you how to treat the packet. It's a slice identifier. There's a path or flow ID that says, if you see this special purpose label, what comes after it is this flow ID, and then you can use that for accounting and stuff. But they also want to use it for this two-phase marking, and there's a draft that describes that. There's generic delivery functions. There's OM data possibly in the stack or beyond the stack. And so there could be a whole bunch of these. And of course, hopefully people are aware that we've already used up half the space, and all the existing requests for special purpose labels cannot be satisfied with at least the base special purpose labels. So you'd have to then go to advanced, the enhanced or extended special purpose labels. So given this background, we took a big step back and said, how can we accommodate this? And so next slide, please. So the key insight is that the critical thing that forwarding engines look at when they're processing a given label, so if you look at the top of stack, you have to look at the label field to say, what do I do with this? You have to look at the TC as part of how you treat the packet. You have to look at the TTL, whether to drop it or forward it, and you have to change the TTL. And then you, of course, have to look at the end of stack bit. And the primary reason for looking at the end of stack bit is to say, what else in the label stack am I going to process? So we've been talking about readable label depth, but in principle, if you can, you would like to go through the whole stack and maybe get to the end of stack and look at things there from the point of view of processing an IP header and getting a better sense of how to forward the packet, how to load balance the packet. So if you do want to do anything beyond the first and the top label, you have to be keeping a close eye on the end of stack bit, because you need to know when the stack ends. There are forwarding engines that look at the label values, and they look for things like SPLs, special purpose labels. So they look for, they They feed them all into their entropy engine if they're so inclined, and so on. So you're looking at the end of stack bits, you're looking at the 20 bits of label value, but the TC bits and the TTL bits are not acted upon. So then I mean, given that insight, the question is, if it is a special purpose label, and if you guarantee that that doesn't reach the top of stack, and if it does reach the top of stack, it is an error. What do we do with, how can we use these bits that are kind of being wasted? So, of course, if we're going down that path and we're going to look at the TC bits and the TTL bits, we have to be very careful, very sure that these labels do not reach the top of stack. Next slide, please. So defining a new special purpose label, or even an extended special purpose label for every new feature, is not a great idea. I mean, first of all, we're running out of regular special purpose labels, and this whole approach is expensive. Typically, it means that you have to do a hardware respin or a microcode change. So the proposal is to use a single base special purpose label to compactly encode multiple forwarding actions in an MPLS label. So you could, for example, use this single new special purpose label, which we're calling a forwarding actions indicator, as the special purpose label for entropy, for the GIS, which is a slice identifier, whether or not you should do fast reroute, whether or not there's OM in the packet, whether or not there's a path identifier in the packet, whether or not they generate delivery functions. The EL already has an ELI, but all these others are active requests for special purpose labels, and some of them want 2 or more special purpose labels. So, so we're proposing a special purpose label called the forwarding actions indicator that uses the TC and TTL bits to encode more data. And this special purpose label can be accompanied by forwarding actions, which are also compactly encoded. And I think this, and the reason why I think this is important, I know that there's going to be all kinds of people lined up. I'm surprised it's just Stuart for now, but if we do find a way to make this work, that means that every code point for a special purpose label can actually do lots of things. And if that code point can do lots of things, we should, in fact, maybe think about if we define new special purpose labels, how can we make them do multiple things? And also maybe go back to old special purpose labels and say, how do we make them more effective? So that, yes, we have only 15 of them that we can use, but the 16th one being the EL extension label, so leave that aside. But can we get a lot more efficient with them and actually, even with those 15, do lots more things? The trigger for this was the global identifier for slice selector, the GIS field. And this enables MPLS-based transport network slices, so you can look at the draft. But we're generalizing from that. So next slide, please. So here's the theory of operation. You have an existing forwarding label that you're looking at. So you have, it's got a TC bit, it's got an end of stack bit, which hopefully is 0 because there's more coming up, and some TTL field. But below that, you have this multipurpose special purpose label. And the bits that I have here are slightly different from the bits that I have later in the slide, which I was going to present to pals. But the idea is that you have a bit that says there is something beyond the end of stack. And maybe there's a bit that says there is something beyond the end of stack, but you don't need to worry about it now. This is only for the end-to-end thing. And there's a bit that says there's something beyond the end of stack. But it might be interesting to you on a hop-by-hop basis. So those two potential bits are there. There's a bit called the header that says, I've got an extended header. So the next word, the next label field is actually not a label, but an extended special purpose, sorry, more bits for this multi-purpose special purpose label. And then you have...
It at 8:45. Now it's 8:55. It's at the 10 minutes mark. Please, yeah, I know that you asked for 10 minutes slot. I'm just reminding you that you're crossed the 10 minutes. I will try to give Jeffrey, I'll be fair with, with the approval of the co-chairs and the audience. Maybe we can go beyond 5 minutes more, but please try to wrap up.
Okay.
If you, thanks.
Interesting that I'm the one that gets my time check and everyone else gets whatever, but fine.
Because you complained.
Exactly. Yeah. Right. That's what happens. So the idea then is to encode in the action bits that you see here the different types of special purpose labels, and based on those action bits, they may be associated data. So if the action bit is no further faster out, there isn't any associated data. But if that action bit says I carry entropy, then the associated data would be entropy. The other thing that's important to realize is that associated data could be all 31 bits. Again, subject to this whole question of being able to reuse the TC and TTL fields. So if you think about using a single word for both entropy label, I don't know if everyone's seeing this, but I'm seeing something funky. So if you see entropy label and slice ID, instead of trying to squeeze everything into 20 bits, you actually have 31 bits. And I think that entropy of less than 16 bits, I think, is pretty much useless. And a slice ID of less than 10 bits, I think 10 bits is already too small. So the idea that you have 15 bits of slice and 16 bits of entropy, I think is reasonable. But if that's not enough, we have an option where you can do more. The higher order bit of all this is, I think this is something that the MPLS working group has to look at and say, does this really work? And can we actually reuse the TC and TTL bits if you're not at the top of stack? And if you can, that really opens up two ideas. One is that a special purpose label can have multiple purposes. And so now each code point can actually be much more effective. And the second is any associated data can have a lot more interesting data. So it's not limited to 20 bits of data field, it can be 31 bits. And so I'm going to leave it at that, and I'll let the chairs decide how they want to proceed.
We do want to take a question at least. Oh, in fact, let me ask the co-chairs what's their perspective on this. Loa, Nick, are you okay to, we take extra 10 minutes beyond the session today, or?
Yeah, it's okay for me as long as the session runs that long. Not sure about Meet Echo.
Okay.
So what I've heard from previous sessions is that Meet Echo doesn't actually end the session, but I mean, people may want to go to Gather Town or something. So I don't know if they've changed policies.
Another alternative is to take the questions after Jeffrey gives his talk.
Actually, if people have a question for Kriti, I think it's better for Kriti to proceed first.
Thank you, Jeffrey. Thanks for volunteering that. Stuart, go ahead. I see you in the queue, and you're at the top of the queue.
Right. So first off, I'm a bit worried that we're tending to put things in the special purpose labels set when we're we should be putting them actually in the FEC. So, for example, you quoted the case of do not fast reroute. The obvious way of dealing with that would be to send the original packet on a FEC that had the property that it was not to be fast rerouted, and that would be consistent with the existing MPLS architecture and not need an extension. Second, you said that these special purpose labels mustn't be at the top of stack. There are some that do go at the top of stack at the moment. GAL is a good example in a PHP LSP. So we do need to be careful about backwards compatibility, although perhaps you meant the new ones must not be at the top of stack. And thirdly, about putting other bits and data in the stack. The ITU wanted to do this some years ago, and we gave quite a sort of sharp reprimand for suggesting this. Part of the basis for that was that there was hardware that was deployed at the time that would actually fall over if you tried to do it. But we do need to be consistent with ourselves, or at least be prepared to justify why we have changed our minds, given the rather difficult conversations we had on this very topic not that many years ago. Thank you.
If I can respond to that, thank you, Stuart. I definitely agree that decisions that we've made in the past have to be rethunk, and telling the ITU what we said at the time. We've changed a lot of things in the forwarding path. So this idea that we have deep stacks, the idea that we actually look well beyond the stack. Well beyond the top label, and in fact, even hunt for the end of stack and do stuff with it was something that was very difficult to do, and sometimes, we didn't want to force that decision, but we've already gone down that path. So we do say that, for example, look at the labels and gather them for doing better entropy, even if you don't have an entropy label indicator. Yes, to your question about my suggestion was not that the special purpose labels never appear on top of stack, but the special purpose labels that do twiddle with the TC and TTL bits should not appear on the top of stack. So, for example, in many cases, if you do PHP, but the ultimate hop wants to see a label, you push label 0 on that. So that's the case where a special purpose label is on top of stack. So there is a slide which we haven't gotten to, which talks about next steps. That basically says people who have forwarding engines. Thank you. You were just there.
Oh, sorry.
Back. No, it says on top next steps. So, yeah, here, proposed next step. So the last slide, last bullet basically says, ASIC vendors, please look at this proposal and send the authors feedback. So the idea is that, we've talked with Broadcom on a couple of their chipsets. We've talked with our own ASIC designers. Definitely that has to be done. And to some extent, being backward compatible is important. And, there are things in the field that will remain in the field for a long time. And the question is, can we not do damage with them? But at the same time, the position that we're in, where we've already overflowed the number of base special purpose labels, and the fact that we're using these special purpose labels, in this very single purpose way, is not the ideal way of going forward. So I think it behooves us to look at this. I'm not saying that it's a slam dunk, and see, is it possible or not, and how can we make it safe?
Yeah.
Go ahead. Why your song?
Hello. Yeah, I've just commented, and I find this the idea here and the concept here is very similar to draft we submitted 2.5 years ago is about proposing extension header for MPLS to support a stack of network functions. I think, in my opinion, our proposal is actually simpler and provide more features to allow us to quickly access any extension headers after the MPLS label stack. So if this idea is interesting, I urge the working group to re-examine our proposal as well. Thank you.
Thank you. You want to add to that, Kriti?
So I'm sorry, I missed that that draft. I will go and find it and look at it. But the idea here is that there is special purpose labels with data in the stack, and then there's data beyond the stack. And for the data beyond the stack, the idea is just to have a bit or two. The reason for 2 bits is from the IOM proposal. So you can have a bit saying there's data beyond the end of stack, but you don't need to see it until you're there egress. And there's another that says there's data beyond the end of stack, and you might be interested in seeing it even if you're a hop by hop, a transit router. But we're basically assuming that what comes beyond the end of stack is self-identifying. So it's in a TLV format, and you know how much there is, so we don't have to do a lot of stuff there. The other part of this, the bits that we didn't get to, the action bits, essentially say that the labels below the FAI label are actually not labels, but forwarding action data. And so you're encoding within the label stack stuff that might be interesting. For example, if you look at the ELI basically said the next label is an entropy label. It only had 20 bits of use, but that same idea is being extended here. And so the action bits would say, I've got 31 bits in the next word and 31 bits in the word after that. And so I could have the 31-bit entropy header and entropy label and the 31-bit GIS, the slice indicator, and so on. So the idea of the action bits is within the label stack, here's what's going on. And then there's just this extra bit or 2 bits, depending on how the MPLS group wants to go, saying there is data beyond the end of the stack, which you can now look at and parse. So it's really about trying to get stuff in the label stack.
Okay,
but I will look at your, yeah.
Oh, okay. I don't think we can take more questions. Jeffrey, do you think you can? Thank you, Kiriti. Thanks a lot. I think we can follow up on this on the list as well. Jeffrey, do you think you can wrap up in 10 minutes? I mean, you can present in 10 minutes. Is that something doable on your side?
I'll do 30 seconds.
I'll leave it up to you, given the constraints. Go ahead.
Yeah, I'll just do 30 seconds. This is an update to a presentation I did last time. But this time we wanted to have more MPLS specific discussions in the MPLS group. We didn't have time to do that, but there is a presentation on the same topic in the joint session with Pao on Friday. I would encourage people to attend to that session because while generic delivery function is intended to be applicable to any layer, including MPLS, there are many MPLS related aspects that we want to have a discussion within MPLS group. Listening to today's presentations, I realized that this new idea of VTM, if we are going forward with that proposal, that we may also consider doing that in the context of a generic delivery function, so that it is not only used for MPLS, but also used for other forwarding plane as well. So I really want to encourage people to read the draft and then join the discussion on Friday. That's it from me.
Okay, thank you, Jeffrey.
Thank you from me too for giving me time.
No problem. Thanks, Kiriti. And thanks everybody for attending this session. It was a pleasure seeing you again. We will see you next time we meet. And hopefully, remember there's a joint session on Friday. We do hope to see you all there. Any last words from you, Leloa and Nick? Please go ahead.
No, nothing from my side. Thank you, everyone.
All right. Leloa, I guess you were having problems with the mic.
Yeah, he has audio problems, so.
Okay. All right. Thank you so much. See you on Friday and during the week. Bye.
Thank you.